Hi everybody, good morning. Happy Tuesday. Hope you're well. Hope you're good in your part of the world. I know I get followers from all over the world. So really hope that you're well and that you and your family are well. But I'm really glad we're going to be spending some time together. I'm feeling a little bit rushed right now because, part of the fun for me to be doing this content creation is that I get to be spontaneous because I can choose to do whatever I want. So today I was inspired to share a project idea that I'm going to be giving away. And I really just decided that in the last 20 minutes. So I've been quickly putting together some things, developing some ideas in my mind. I put together like just 3 or 4 different slides to show you guys, reviewing some materials. So I'm feeling a little bit rushed just because I did all that in the last 20 minutes. And then I also have to start up my stream, on my big old setup here. And it takes me about like 5 to 10 minutes just to set up the stream, to do all like my broadcasting software and all the connections and the promos and all that. It takes like about 10 minutes to start up. So we're going to calm down. We're going to slow it down a little bit, and then we'll get to the project idea. By the way, if you are looking for the project idea, it's probably going to be better to be on YouTube just so you can get the wider format. You're welcome to stay on Instagram. I'm going to keep on pushing it on Instagram. But I did get some feedback this past Sunday, about how it doesn't look so great on Instagram. Instagram only gives the narrow view. But with some of the stuff I'm going to be showing, it might be better for you to see it on a wider screen, YouTube, or I'm also on Twitch, LinkedIn. What else gives you a wide screen? I think that might be it. But yeah, just wanted to spend some time with you guys because, it's fun to always talk about data science. And as you all know, we do the morning roll call, the global roll call, as soon as we start off. So Rohan, once again, has understood the assignment. He has gone ahead and told us where he's from. So please go ahead and introduce yourself and let me know where you're from. I love hearing where everybody is because I love traveling, so I love seeing what a global community we're building here. I'm really happy to see everybody joining us today. And by the way, speaking of communities, I want to show you guys the Discord community that we've managed to build. I'm so happy that people are really, taking to the community and joining us there, really having some good discussions. So if you haven't joined us already, feel free to do so. The link is in Instagram on my highlights. Really great discussions where people are posting different things, different thoughts. 54 people have already joined, something like that. Which is way more than I thought. So yeah, come join us, come talk, come share your ideas. I'm also pointing this out because after we talk about today's project idea, I assume that you're going to have questions, or maybe you want to team up with somebody, or you want to post your work for review, whatever the case may be. Feel free to do that. The Discord is really the best place to do that, right? I try to keep up with the Instagram comments. I do a pretty good job of replying, but that's not always great for when you may have like an in-depth question, right? So feel free to do that and let me, contribute to the conversation. I love the community helping each other. I give my opinions when I can, but yeah, I just love the community being able to kind of help each other along. Okay, so let's go ahead and remind everyone, if you're joining us just a little bit late, we do our global roll call. Let me know where you're from. I'm going to go through the chat, give you guys some time to let me know, just kind of introduce yourself quickly. And yeah, I can kind of go from there. All right, so let me go up here. Amina Blue 15 says, hi Dennis. Hi Amina, nice to see you. I don't think I've seen you join the chats before, so go ahead and introduce yourself. Just let us know what the city, state, province you're from. That's all you have to tell us. No one's going to call on you or anything. And by the way, guys, I know some of you are regular watchers, but I repeat the global roll call because my Instagram account grows by about 125 to 150 people a day. So in between, 3-4 days of streams, there might be like 500 people that have joined, right? So I try to kind of repeat that just to make everybody, welcome and wanting to participate. All right. Abdul84 says, hello, sir. Hey, Abdul, good to see you again. I know you were here yesterday. Hope that you're well, my friend. Abdul, remind us where you're from. I can't remember if you told us that yesterday or not. Saketh, let's slow down. Pump the brakes. We're not at questions yet. In fact, we're not going to be at questions for a while because I want to get to this project idea. Because I think that might lead to more discussion too, right, guys? Hamad, my good friend, says hello, sir. Good morning. How are you doing? I'm doing well, thank you. I didn't sleep so great last night, so kind of getting a slow start to my morning. I got a lot of things to cover today. Both here and personal stuff. So lots to do today. But thank you for asking. Rex, good morning, everyone. Good morning, Rex and Patrick. Also, good morning. Rex and Patrick are two of our big participants on Discord. Doing a great job of helping each other, helping the community. So if you guys want to come by, that's a great place to talk to good people like Rex and Patrick. Saket says good morning. Good morning to you too. Lakshmi Ande says good morning. Good morning, Lakshmi. Good to see you here. Lakshmi, I see that I see that you're on Instagram. You're welcome to switch over to YouTube for the project portion, just because I think it'll be easier to see. But it's good to see you on Instagram. Joseph, our good friend, also a big participant on our Discord. My morning is going well. Thank you so much. Just I had to stuff a lot of work into about the last 20 minutes getting everything up and running. But that's the fun, right? It's we can be spontaneous. Yep, Rohan, good to see you again from Vizag, India. Saket says, "Is there a place where I can find your materials?" And for an aside, I want to know what you have to say. So, Saket, basically everything I broadcast is also put up on YouTube, and the replay is saved up there. As soon as the live event is over, it's saved as a replay on YouTube, and you can find anything there. So for something like today, where it's a project example, you might want to refer to it later. Even if you attended, you might still want to go back and review it. Go to my YouTube, it's on my replays, and you can find it there. I never remove them. Rex, that's right. Rex is our man in NYC. Hope everything is well out there. I still have friends out there in that area, and I'm hearing it's super hot out there. Okay, so Saket shares that he's from Charlottesville, Virginia. Okay, very cool. I lived in Northern Virginia for about 6 years when I was younger. Patrick is checking in from Knoxville, Tennessee. Let's go Rocky Top. Yeah, you know what? I don't think there's a finer community college than that. So good job for you, Patrick. And hopefully you'll be able to finish out at that community college. Okay, Ahmed says he's from Haripur, Pakistan. Good to see you, Ahmed. We get a lot of viewers from Pakistan and that region of the world. So glad to see you here. Saket said there's only YouTube, Amazon, and calendar links on your Insta bio. Well, what else do you need? That sounds like a good list. You say that list like it's a bad thing. I think that's a pretty good list, Saket. Shashir is checking in from Nepal. Very cool. My analytics show quite a few people from Nepal, so nice to see you. Joseph Hernandez says he's checking in from Johnson City, Tennessee. I know you said that's East Tennessee, but I don't know more than that. I've never heard of Johnson City. East Tennessee, that's also where the, what do you call it? The Smoky Mountains are, right? I think that's East Tennessee. Ah, okay, Abdul, you're in Boston. Very cool. Great city. Heard it's super expensive to live there, though. I've had job offers to work in Boston. I remember maybe 8 years ago, somebody offered me a job in Boston. And I went and researched the cost of living. Wow, I did not realize Boston was so expensive. When did that happen? Labd Allah says, "Hey Dennis, I'm Mandy Badouin from Pakistan. Hope you're doing okay." I'm doing okay, thank you. I wanted to know, where does web scraping fall in the data science sphere, and is it worth doing as a freelancer? Labda, let's go ahead and save those questions towards the end, because I'm presenting a project idea today that maybe you'd be interested in, right? So let me go ahead and, come back to that. 7AQ coming in strong with the questions. Didn't even bother to introduce themselves. So bad. Gonna come back to your questions later, okay? Okay, Lakshmi says that they are from Saratoga, California, and I work as a data scientist in AI product-based software. Okay, very cool. What level data scientist? Usually people are given levels, or just let me know what year you're in. I'm curious about that. And you're in Saratoga, California. That's up north, isn't that like Napa Valley? That sounds familiar. I think that's like Napa Valley, isn't it? Let me know where that is. Praveen, our good friend, our good regular. Hey, hi, hello, Dennis, sir. I'm doing. Good morning. Nice to see you. Yep, Patrick is kindly providing the Discord link there. The Patrick is, excuse me, the Discord is really become a great resource. So I'd highly encourage you guys to join. Look forward to having more discussion with you guys there. Again, especially if you're coming to, sessions like today where I'm going to kind of, almost like teach a class. Or on Sundays, if you come to the Introduction to Statistical Learning book walkthrough. The Discord is a great place to follow up with good guys like Patrick and, ask questions and kind of have the community help themselves. So thanks for posting that link there, Patrick. Shashir says, it's already dark here in Nepal. Good evening. I love the way you explain things. Oh, thank you so much for that. Yeah, I know that this isn't a great time for Asia, but it's the best time slot I could find. I realize that for Asia, it's super late. But Shishir, I am offering some streams that are more convenient for the Asia region. So keep an eye out for those. I ran a test last Thursday and it worked out well. So yeah, keep an eye out for those. Go to my YouTube, subscribe and notify, and it'll tell you when I'm going live. And yeah, I will be trying to be more aware of that and do more Asia-friendly streaming. Mansi, I think you're new, so I appreciate you joining us. Mansi is from Bangalore, India. Welcome. Patrick shares, Rocky Top is the nickname for the Community College of Tennessee. Cool, good for you, Patrick. Sounds like a fine community college. Okay, Joseph Hernandez says, "Yep, it's in East Tennessee," and I guess that's the yup for the Smoky Mountains. But yeah, I'm gonna assume it's there. Okay, Saketh said, "Sorry, I wasn't clear. I'm looking for your Discord. I would be glad to join the community." So Saketh, look just a couple messages earlier in the chat. I believe that Patrick posted that. Well, actually, he posted it on YouTube. So I will, you know what, Saketh, later today, I will post a new story with a link to the Discord. I've actually been meaning to do that. Because, I really want to thank all of you for being so active in there. Again, 54 people already in there, so I'm gonna advertise that on my Instagram later. So look for that later today. I promise to do that. And Abdul is making sure he checked in on YouTube. Very cool. All right, guys. So if you're joining us late, feel free to introduce yourself, city, state, province, country. But I want to go ahead and get into the project idea, because a lot of you guys approach me about projects, and a lot of you ask for it in the chat. Surely you guys have seen that in the chat where people pop in and say, hey, what's a project idea, so on and so forth. So I'm gonna do that today, and yeah, so let's start with that. So when it comes to data science project ideas, if you've watched my content before, you know that I'm usually hesitant to do that. I'm usually hesitant to do that because coming up with your own project idea is really a wonderful opportunity for all of you to exercise your creativity, right? It's a great way for you to kind of apply your view of data, your view of data science to basically anything you want in the real world, right? So I'm usually hesitant to do that, but today I want to show you an idea for a couple of reasons. One, because for somebody with my experience, I get ideas all the time, right? I see all kinds of ideas all over the place. But I don't always have the time to do them, and as I'm getting older and all, I kind of feel like I'm running out of time, right? So sometimes you have to start giving away project ideas because I want to put my focus and energy on other things, right? I don't always have time for all the ideas that come my way. And the second reason is because if I walk you through this, maybe I can kind of set up a framework for all of you to think about how you would approach these things in the future, right? So the intent of today's session is to kind of help you with that framework. I'm not necessarily opposed if you go ahead and copy this exact project, because I think there's so many different facets to it. But where you really win, where you as an individual win, is when you say, okay, yeah, Dennis showed me the framework, but here's how I'm gonna develop it using my own tools, my own data, my own projects, and kind of take it from there, right? I mean, that's what I really am encouraging all of you to do. Because remember, my whole point of doing content creation is to help the next generation of data scientists, right? You know, this is me after many years in the industry, having a long career. This is me reaching my hand back and helping, you know, all of you also come up and, you know, kind of come into your own right as a professional data scientist. So I'm going to walk us through that today. You're welcome to look at this project idea and build on it, or, you know, just understand the framework. You're welcome to join the Discord, and, you know, maybe you're going to find a partner there that you want to collaborate with. Maybe you want to share your findings. Maybe you get stuck on something. So feel free to join the Discord also and, you know, kind of contribute there. Okay, so I prepared these slides, and you're going to have to forgive me if we spot any errors, because I prepared them just prior to starting this session, because I'm being spontaneous. You know, I can come up with this stuff in a couple minutes, so it's just, I'm just being spontaneous, decided, you know, to do this. So what is a good project that we can add to our portfolio? And also, I hesitated to use the word portfolio here, because you shouldn't be thinking about this as just like something you're going to use to send to a recruiter or for a hiring cycle or for interviews. That's not really the point. The point of a project is to develop yourself as a data scientist, right? I often talk about doing the work, putting in the time, dedicating yourself to the profession. If you're really serious about that, then you're doing projects all the time. I find myself doing projects, you know, tons of them. Most of them don't really see the light of day. Sometimes I might stop at a certain phase because I wasn't enjoying it, or I wasn't liking where the findings were going, or things like that. But the point of this is to just kind of, you know, keep on developing your skills, keep on working on your craft, right? But generally speaking, we want something that's an interesting topic. We want it to be an interesting use of data science, right? You know, kind of contribute to the greater data science ecosphere, right? And then we also want, hopefully we'd want something that we can find with real world impact, right? Something that's going to mean something. That makes it a little bit more relatable to people. Maybe it certainly makes it into more of a commercial product, you know, because who knows, maybe a project turns into a startup that you find some collaborators with, and maybe you can develop a startup from it, right? So those are the types of things that I'm looking for when I want to start a project. So we're going to walk through an example of how I would develop a project idea, and how I would determine how I want to go about it. And my intent today is I will only really present the structure of the project for you, and I'm going to leave it to all of you to, you know, move the ball forward and execute the code or execute the overall development of it. Now, if you get stuck or you need help on the theory or something like that, I'm willing to help. And then you guys can kind of keep going from there, right? So I'm presenting this, you know, just kind of putting it out there, and then I kind of want to see who picks up the ball and runs with it, right? Maybe you guys will want to work with it a little bit more, or maybe it doesn't interest you at all, or maybe you just want to take the framework I'm laying out and do something else, okay? All right, so excuse me, sorry there, I pressed the wrong button. So we are going to be using a product by Meta known as Profit. In my opinion, I shouldn't say my opinion. I am consistently surprised by how lightly used this library is. So what is it? It's a library for time series analysis, for really quite advanced time series analysis. And it's really just not nearly as used as much as you think it would be. I've done a couple inquiries on some message boards and things like that, and I really can't find a lot of people that have adopted Profit, but I've used it for some client projects. Well, first of all, it was introduced to me by another data scientist who I highly respect, right? You know, that's part of the benefits of collaboration when you get more into the industry, where you start collaborating with others and maybe they turn you on to different things that you didn't know about. So I was introduced to it that way. It's a very well documented library. It takes a lot of the complexity out of time series. So if you've done time series on your own, which can be done, you can do time series with pandas in a neural network, right? There's tools out there for that. It's pretty complex to do it on your own, but it can be done. Profit helps a lot with that. And I think it's a pretty good library for time series analysis. And as I mentioned, it's also very well documented, which not every library out there is, right? So that's why I like MetaProfit. I think it's really highly underutilized. In that lack of utilization, it might also signal an opportunity, right? Because a good tool is still a good tool whether people are using it or not, right? So that's why I think that there's an opportunity here with Profit. I've done some of my own experimentation. I'm not going to talk about the data that I was using, but I think that it is possible for you to take this and maybe develop something that maybe not a lot of people have seen before. Maybe there is an opportunity for a product here, right? Because there's just not enough being done with time series. Right? Time series is not easy. There's not a lot of people you're going to find that specialize in time series, right? Some people, in fact, can maybe be a little intimidated by time series. So that's why I want us to focus on MetaProfit, and hopefully it'll give us something that people find interesting. Okay. So what else do we need to do here? So if we know that we're curious about MetaProfit, what do we need to do, right? Because remember, whenever we're talking about libraries like MetaProfit, scikit-learn, learning Python in general, neural networks, all of these things, these are just tools, right? But we have to know how to work with them, right? How to actually utilize the tool. A wrench is only as useful if it's in the hands of a good mechanic, right? And the mechanic has to understand that wrench. So that's what we're going to do a little bit today, right? So the things that I want to know when I'm approaching this is I want to know, one, how to get started with the library. Two, how can we, oops, excuse me, I made a mistake there. I want to know how we can apply a solid methodology, right? Because remember, data science is not an algorithm, it's not a result, it's not math. Data science is a methodology, it's a process. It's how you go about creating an algorithm that gives you a probabilistic answer, right? That's data science in a nutshell. So I want to know how I can apply a good methodology to this, okay? I also want to identify the metrics that we can use during our methodology, right? Because remember, we're going to be applying the scientific method, right? And applying the scientific method is experimentation, right? We're going to be experimenting with our data. That's the science part of data science, right? So what are we going to measure those results against? We have to have some metric that you can measure against, right? So what are those metrics that are available to us? It varies by model, it varies by project, right? So I want to know that ahead of time. And then finally, the last step is we're going to start an ideation process to determine the projects that this is applicable to. And I'm kind of laying it out like this because sometimes most of us put that bottom bullet, the ideation side, ahead of time, right? You start off by saying, oh, I bet that if I did an algorithm like this, I could sell that and it would be a good startup. And that's not what we're doing here, right? What we're doing is we're taking an educated approach to a new tool that we think, has some potential. So I want to learn the tool. I want to educate myself on the tool. And then I'm going to go into an ideation process, right? Because now I'm the trained mechanic, right? Now I'm the trained mechanic that says, I'm a data scientist. I understand the process. I understand the methodology. And I've added a new tool, MetaProfit, to my toolbox, right? So then we're ready to start the ideation process, not before, right? So I'm taking my time in this because I want to make sure I'm impressing that upon you guys, because methodology is so important in data science. I have an entire discussion on methodology in my book, Your First Year in Data Science. It's available on Amazon if you're interested. But methodology I always tell my first year data scientists who work for me, if you learn nothing else from me, learn about methodology. I will teach you about methodology. Because that's really what it all comes down to in your first year in data science and throughout your entire career. So this is the type of methodology that I want to run you through, that you should be thinking about when it comes to new projects or new tools, or even showing up at a new client site, right? Showing up at a new job. Okay, so I think that's my last slide. Let's go over. So when it comes to things like this, we're going to become best friends. Give me just a second. Okay. We're going to become best friends with the API documentation that's available. And as I mentioned, this happens to be a very well documented API, right? So this is available on GitHub. It's directly by Meta or by Facebook. I don't know why it's listed as Facebook. I think they distribute everything as Meta now. But it's available out there, and it's a great, nicely documented API. So I'm going to go ahead. Well, first of all, realize that there's a paper there, right? And you're welcome to read the paper to understand the underlying, what's going on underneath the hood. But really what you want to do is you want to click on the get started for whatever language you want to work on, right? Because here's the first thing I want to establish, right? Can I install this? Does this work in a language and in an environment that I'm familiar with and I'm comfortable with, right? So the first thing I'm looking for is yes, they make it available in Python, and the imports are pretty straightforward, right? It's telling me that this is the import statement and that pandas is one of the dependencies. Pretty straightforward stuff, right? I think most people who have done even a little bit of work in Python have already done work in pandas, right? It's hard to do data work without pandas, right? And then they also show me an example of the data, of the type of data that they expect, right? They're giving the date, right? Or the date in the series, right? And I think that's what the DS denotes, the series. And they're giving the Y value. And that's it. That's the only data that you need, right? So let me get some audience participation here, guys. Okay, I know we have quite a few people in the chat. So what is a Y? If you've been attending the ISL classes, you should instantly know this. But, you might know this already on your own, right? There is a name for the Y variable, right? And in some ways, there's kind of a name for the DS variable in this situation, although it's a little bit unique. But can anyone tell me what the Y variable, the Y column here is known as, right? I'll give you guys a minute to think about that, but there's a name for that. And by the way, guys, I see people still joining us on Instagram. If you want to go ahead and join us on YouTube, it's a little bit easier to see the classroom view. I am Data Science with Dennis on YouTube, so feel free to switch over there. That way you can see the entire screen, because I am showing things on the screen. Okay, good. Joseph got it right away. So did Hamad. Anybody else? All right. Well, yeah. I mean, I think most of you guys get it. Okay. Nayan says Y variable is called the target or independent variable. Wonderful. I like the use of target there. One take Fizzy says independent variable. Yeah. Yeah. Actually, yeah. No, I'm sorry. I read that too quickly. So Nayan, you got it backwards actually, okay. So Nayan corrected themselves. A dependent variable. Yep. I like that. The Y can be referred to as either the dependent variable or the target variable, right? So for those of you that aren't comfortable with those terms yet, it's basically what we're trying to predict. What is it that you're trying to predict? What is it that you're trying to find, right? So that Y variable is what Profit excels at. Give me the dates Give me the time series, and I will tell you a prediction for y, for the dependent variable, the target variable. That's essentially what Prophet excels at. And the great part about it, or arguably the not so great part about it, is that this is it. This is the entire data structure that you need in your input files. This is it. It's just two simple columns. But thanks a lot for the participation, chat. You guys are on the right track. So good. Okay, so the documentation, and we're still in the quick start here, right? The documentation goes on to tell us about how to do a fit. Here's how we do a model fit, right? We can assume, because we know pandas, that DF refers to a data frame. They don't explicitly say that, but they've already given us what our data frame should look like above. And here's how we fit it, right? Again, for some of you that aren't comfortable with these terms yet, usually in APIs and in libraries, when you hear the word fit, you should be thinking about training. This is where it's training an initial model. Okay, so fit is like training. And then here, it's telling us how we can do a future instance, a prediction, right? It's telling us that the future is, it's setting the variable future, and it's using a method called make future data frame for how many periods you want to predict into the future. And then here you're just printing out the tail, because this returns a data frame, and then you're asking it to show you the tail of the data frame, which is the end of the data frame, right? Excuse me, I'm sorry. This is telling you the periods that you want to create predictions for, and then down here it's showing you how to actually do the prediction on however many dates you chose. Right, so I apologize for that. In the top section, it's how many dates you want to create predictions for. They have to be in the future, and then here is where you're actually doing your prediction. And then if you're still a little lost, you might be wondering what the M stands for. M is the instance of Prophet that we established in an earlier piece of code, right? The point here is not to say, great, I'm going to take this, I'm going to copy it, and I'm going to start working with it. The point here is to verify that all of the methods and all of the code that you need for your general data science process are present and you understand them, right? Because we're gonna have our data, we're gonna look at our data a little bit, we're gonna do ideation, we're gonna try to create a model, right? We're gonna try to fit a model, we're gonna try to train a model, so we know we have fit functions that are available, and then eventually we'll land on a good model, and we want to know how to use it to make predictions, right? Our runtime predictions. And we have those components here, right? So we're not making any judgments yet. We're not thinking ahead to the projects. We're just verifying that we have our understanding of the API fits the methodology that we want to apply. All right, you guys with me on that? I think it's fairly straightforward so far. If you're a little lost, that's okay. Join the Discord, get some help there from the community. Come and learn on the Sunday classes that I'm running. But I think that most of everything I've covered right now is digestible for most of you. All right, so we know that Prophet has some potential as a well-documented tool. We verified that some code is available there that we can use. How do we install it? So I'm going to go here. I'm going to look in the installation, and we're going to say that we're Python people, but you can also be an R person. Prophet is available in R. So, I would point you to those sections. There's an installation in R, but then down here, there's also an installation in Python. And it looks pretty straightforward, right? It's a pip install. It's a pip install, which means it's out there on the repositories, and it's also out there on Conda. If you prefer to manage via Conda, I prefer pip. You can actually mix the two if you want to. But it's also verifying that I have to use it at least on Python 3.7, which is a reasonable ask. I think most people are way beyond that by now. Actually, way beyond that. 3.7 is a while now. But all the requirements are there for us to work with it. We know how to install it. We know how to instantiate it, right? What imports we need. And then we know that we have a fit and a prediction portion for it. And that's it. That's all we need to know at this stage, right? We're not getting ahead of ourselves. We're not, we're not jumping ahead to ideation or anything like that. We just want to make sure that it's a viable library for us to implement in our process, because we're never deviating from our process, right? The data science process will always be that way, no matter what project we choose, no matter what tool we choose. So we got to make sure that the tool is acceptable for that. And we verify that, so that's good, right? So the installation is pretty straightforward. So now, I want to look at a couple of things. Yeah. So remember that we talked about these metrics, right? We talked about how is it that we're actually going to measure our, well, one, how are we going to run our experiments? And two, how are we going to measure our experiments? How do we know that our model is good or bad, improving, not improving? We need to know all these things, right? That's the data science part of it, right? That's the experimentation side, right? So, what a couple of things call my attention here. I'm looking at the what do you call this? Like the table of contents or whatever, right? Because I definitely want to read about everything else that's available. But again, I'm still thinking from a meta perspective of, does this fit my data science process? How do I work with this? And also, the things I'm showing you today are kind of like common in most libraries, in the good libraries. Like, you're not going to find seasonality in some libraries; it doesn't apply. But you should find what you see here in the diagnostic section, because that's what's calling my eye. My trained eye is going to the diagnostic section. Cross-validation is catching my eye, and hyperparameter tuning is catching my eye. And also the parallelizing, but that's secondary, and we'll get to that, right? So this coming weekend, on Sunday, I'm teaching the Introduction to Statistical Learning book, and we're actually going over cross-validation. That's the next chapter. So here, let me bring up the book, so we're all on the same page. This is the book. This book is where professional data science begins. Every Sunday I'm teaching a class. We've had 2 classes so far, and they've been fantastic. I'm seeing some of the people in the chat today that are attending on a regular basis. Joseph, Rex, Patrick, couple other people that are also attending. I'm sorry if I forgot your name. This coming weekend, we're doing cross-validation, chapter 5? Yeah, chapter 5. Wow, can you believe that? We're already halfway through the book. Good job, guys. So, it's cross-validation. Does anybody in the chat want to give me the elevator pitch on cross-validation? And by the way, this is an interview question I ask, because I like asking the theoretical questions. So what is cross-validation, guys? Go ahead and put it in the chat. If you don't want, if you're not comfortable, that's okay. You can just hang back. No one's gonna call on you. You don't have to answer if you don't want to. But I'm gonna give you guys a minute. Give me your elevator pitch, your brief explanation of cross-validation. Give you guys a minute to think about that. Kozeko says, are the other Sunday classes recorded? Yes, absolutely they are. So if you want to come this Sunday, but you want to get caught up, go ahead and go to my YouTube, look in my videos, and you'll see them there. And I call the videos Introduction to Statistical Learning. So there's 2 of them so far. You're welcome to go there, maybe get up to speed a little bit. Maybe you want to download the book, the PDF of the book. And then maybe come and join us, and you should be ready to go. No one gets called in the class. You don't have to worry about having to participate. You just want to hang back and learn. That's totally fine. But you can find the classes on YouTube. Data Science with Dennis. All right, so giving you guys a minute here to think about what is cross-validation. Give me your elevator pitch on cross-validation. Hamad says cross-validation is validating the model to overcome the issue of overfitting. Patrick says cross-validation is where we split our data into k-folds and fit our model to each fold at one time. Then we evaluate on the other folds. Okay. So Hamad is telling us that we're validating the model. Patrick is telling us that we're using a folds process. But that's not telling me what cross-validation actually is, guys. Like, why would you do this? Like, what is cross-validation? Like, try to explain it to your grandmother, right? Let's take a high-level view here, right? What are we trying to achieve with cross-validation? Okay, so Nyan says cross-validation is a method to validate our data. So basically the same answer as Patrick. But why, Nyan? Like, what are we doing? Like, why does cross-validation even exist? Okay, so Hamad revised his answer. It is used to assess the performance of a model. Yeah, you're getting closer. You're getting closer. Amina, you're asking a great question. I'm going to come back to that, okay? I'm going to come back to that. You're asking a really important question, but let me come back to that. By the way, if you're in the chat and I haven't answered your question, that's okay. I will come back after the class. I just want to get through the class, okay? Kozeko says cross-validation is a process to compare learning algos by dividing the given data into two segments. Nyan says it's done so that data doesn't overfit. Yeah, but why? Okay, Joseph, are you revising your answer? Or is that a new one? I think that's a new one. Okay, all right. I think Joseph has given us the most accurate answer so far, right? Rohan, yep, Rohan. I think you're on the right track. And Hamad, your revision is improved. Yeah, but I'm going to highlight Joseph's answer here because I think he's giving us the best one, right? And cross-validation, you should be thinking about training a model. You're taking some data and you're comparing, you're training a model on it, and then you're letting the model then correct itself based on the answers to that data. That's what it is, right? The example that I use, because remember, we're talking to business people, right? Most of the time. The example that I use is, you know how like when you were a kid in elementary school and you had like math books and like, you would do the math problem and then the answers were in the back, right? Like the last like third of the book with the answers were in the back. That was you as a human doing cross-validation, right? You sat there, you did the answer, or your social studies course or whatever it was, right? You saw the question, you did the answer, you said, "Yep, I'm pretty sure that's the answer." And then what did you do? You went in the back, you checked it in the index or the appendix or whatever, and said, "Yeah, I got the right answer," or "No, I went wrong. Here's where I went wrong." That was you doing cross-validation, right? So cross-validation is the process that a model goes through to teach itself. Okay? So when you hear things like that, what is cross-validation? Just give that type of answer, because that's the type of answer that your stakeholders are going to want. You may know about the folds and this and that, but your stakeholders don't care about that, right? So like when I ask that question in an interview, Joseph is giving pretty close to a model answer, right? Yeah, so really the only thing I would add to Joseph's answer is that it's the process that a model also goes through to train itself overall. It's basically how data science is achieved, right? Because you don't just like, you don't just say, well, here's a math formula, here's my data, go to it, right? Cross-validation is that process where all of that is mixed up. So I'm emphasizing that because that's why it caught my eye. Right? It's the documentation you read on APIs is not always going to say how to train your model, right? They're going to call it by its proper name, which is cross-validation, right? And then, like I said, the second part that caught my attention was the hyperparameter part of it. And we're going to get to that, okay? So we're going to go ahead and click on the diagnostic section. And the diagnostic section tells us about the cross-validation processes and the different ways that we can use to train our algorithm, right? So it's telling us here how we can use it in Python. And then it's giving us a sample output. So I know that some of you have formal statistics training and others don't. But there's two columns here. Well, actually three columns. There's y hat, y lower, y hat lower, and y hat upper. Does anybody want to take a guess at what those are? And then you should also notice we have the y column, right? But even if you don't have formal statistics training, you can probably take a rough guess at what these are. Okay, Patrick, you're quick on the answers today. Love it, my friend. Patrick says confidence intervals. All right. Anybody else? Or maybe you just agree with Patrick. You're welcome to just agree with somebody else's answer. Joseph says predicted value of that variable, I think. Yeah, but yeah, that's one of these columns, but there's three columns, Joseph. Yeah, okay, yep, you're right. You've correctly identified y hat, right? So let's all agree, as Patrick and Joseph both pointed out, y hat is the prediction, right? And then Amina says maximum and minimum. Yeah, exactly. That's exactly right. Hamad, yeah, you got it too. Y hat is prediction. So you wouldn't know that unless you've had statistics training, because y hat and y hat lower, y hat is more from the world of statistics than data science strictly, right? And that's exactly what they are. More specifically, they're kind of like the inferential values of y. You know, if you want to get really academic about it, it's the inferential values of y, right? That's why it's the hat part of it, right? So y hat is basically telling us what the model thinks the answer is. And then y hat lower, y hat upper is basically the range that it thinks y hat should fall into. Or excuse me, what the range that y should fall into, not y hat. So Patrick, you're definitely on the right track. It's funny to say confidence intervals, because confidence intervals is what I would tell my stakeholders, because that, like, everybody kind of understands that. But a statistician might disagree with that, right? A statistician might tell you, well, it's really more of a range, right? So that's why I didn't give you an answer right away. But I think you're on the right track, Patrick, as far as what you would tell your stakeholders or how you would present this in a business meeting, right? It's basically the confidence interval that the algorithm is assigning it. And then y here represents our actual known value, right? So now, if you're able to compare y hat to y, well, now you're getting to a metric you can measure, right? That's that cross-validation part of it, right? That's the training part of it. Because now this is the algorithm saying, here's what I think the answer is. And then this is your ground truth, right? Your ground truth is column y. And now you have something to compare against. And you can say, whoa, wait a minute. Here, the algorithm thought the answer was 8.53, but ground truth is 7.92, right? So now we have like a measurable thing that we can use. It's hard to do data science or any science unless you have something to measure, right? So I'm walking you through this so you can see that this is how the data science process builds, not just with data, but with the scientific method, right? Because now we have things that we can measure, we can compare, we can use baselines, we can improve, we can get worse, we can get better, right? So this is kind of where that process begins. So cross-validation looks like it's pretty good here. And now, in the next section, again, because this is a well-documented library, it's put out by people who clearly know what they're doing. The next section they show you is the diagnostics, the metrics. And here are the metrics that they're showing you, right? So if you've been coming to our Sunday class, at least one of these columns should look very familiar to you. So again, chat, I'm going to give you a little bit of time here. We can know what the horizon is, right? But for the rest of these 7 columns, at least one of these should look familiar to you if you've been coming to the Sunday class. Or if you have, pretty good, data science training, you should know this, right? So some of you told me that you're first year data scientist. I don't want to call in anybody, right? Because, I don't want to, that's not what we do here, right? But some of you should already recognize at least one of these columns. All right, so I'll give you some guys to think about it. Oh, Joseph, what a great question Joseph is asking. Is the error symmetrical, as in are both sides of y hat, plus or minus? Great question, Joseph. You know what? Let's leave that as a homework question. Joseph, you're a smart guy, and we have a lot of smart people in this chat. So why don't we leave that as a homework question for you guys to come back to the Discord and provide an answer on that. I think it's fair to say that there's probably instances that do fit that, Joseph. So if you really want to research something, you should ask, are there instances where it's not symmetrical? So just try to answer that as a binary question and then go from there, right? But great question, Joseph. Love it. All right, so right now the question is, right, we're looking at these 7 columns. The profit documentation is telling us that these 7 metrics are available, right? What do you guys think? If you've been coming to the Sunday class, okay, great. We already have one answer. Anybody else? Anybody else, especially from the Sunday class? At least one of these should look familiar to you guys. All right. Yep. All right, so it looks like Nyan and Hamad are giving us very similar answers, and they're correct. The one that all of you should recognize is the first one, MSE. If you have a background in statistics, regression methods, and other models, MSE is something that should be familiar to you, right? The mean square error, right? As Nyan and Hamad have both correctly identified, right? And it looks like Patrick also agreed with Nyan's answer. But yeah, the mean squared error should be something that you should focus on, right? That's the first thing that draws my eye when I look at this table, right? It's probably too much to ask for a definition of MSE. It's kind of hard to do that in a chat window. But basically, the mean square error says, what did your model predict versus what was your ground truth? And how big were those differences? How can we measure the scope of those differences? How far away were you from the expected values, right? Your model predicted this. Here's where y actually is, or it could be below it, right? What is the impact, the magnitude of those differences? And not just for one point, but as an aggregate for the model. right? That's where like the mean and the squaring comes in, right? To give you a single number for the model. So you don't have to know all of these. You just have to be comfortable with one of these, right? Why? Because you need a metric like this to be able to say, yeah, this model is working as desired, or no, this model is terrible, right? All right, so how will we know that, right? There's a lot of ways that you should consider MSE and all that, right? But generally speaking, and I want everybody to participate, okay? If you're listening to it, I want everybody to participate. Just give me a 1 or a 0. Okay, just 1 or a 0. When we're looking at MSEs, is a higher value better or a lower value better? Give me a 1 if you think a higher value indicates a better model, or give me a 0 if you think a lower value indicates a better model. Right? Because now we have a whole new series of numbers to deal with, right? How do we know which one's better or worse? So give me a 1 if you think a higher number is a better model, or give me a 0 if you think a lower number is a better model. No matter what platform you're listening to, you should be able to do just a quick 1 or 0. No one's going to call on you. Just give me some quick participation there. Nobody think it's a 1, huh? Okay. Maybe all of you are wrong. I'm just saying. All right, last call for votes here. Give me a 1 if you think higher is better. Give me a 0 if you think lower is better. All right. I'm seeing nothing but zeros in the chat, and that's right. It should be lower, right? Because if we just said that it's a measure of the difference between your prediction versus your ground truth, then yeah, you want that gap to be as small as possible, right? You want that mean square error to be as small as possible. So you want to be approaching 0 to indicate a better model. So yeah, congrats, all of you got that right. So that's what you want to be doing. That's the type of isolation you want to know, right? Because now we know how to fit our model and how to create a new model and then how to measure it, right? So if you're thinking about those terms, then you should also be thinking about how you can create an experimentation process, right? Because to be honest with you guys, I never understood the experimentation side of data science until I understood cross-validation, right? Because until you start seeing that, then it doesn't make sense to say you're going to run experiments on data. What? Like, what do you mean by that, right? So now we have something to measure against because we know that different values are going to give us different results. So speaking of that, thinking about what we just said, maybe you can infer what hyperparameters are. So does anybody want to take a shot? And even looking at the code here kind of helps. Explain it to me like I'm 5 years old. What's a hyperparameter? Give you guys a minute to think about that. Give me the 5-year-old elevator pitch on hyperparameters. Patrick says, any parameter that your model doesn't learn from your data. Patrick, my friend, I'm not sure if I'm on board with that. Give me a little bit more. Maybe I'm just not understanding your answer. But as stated, I'm not on board with that. Anybody else on hyperparameters? Okay, Rohan says parameter used to bring down the RME. Okay. Oh, we have a participant from Twitch. Welcome. We don't get a lot from Twitch, so welcome. Great answer, by the way. Geez, N-Sweep, our Twitch user, coming in strong. It's a dial you can turn to change how the machine reads or adjusts to training data. That is a pretty good 5-year-old explanation, my friend. Coming in hot there. Their first message in the chat was dead accurate. Good job, N-Sweep. Hyperparameters are different parameters in any ML algorithm that are adjusted to enhance the model's learning, such as the learning rate itself. That's also a fantastic answer. And you know what I like about this answer is that they also mention how it's different hyperparameters depending on the model. So that's one of the things you should know. Hyperparameters are going to be different for all the models that you work on. So here in time series, we're going to see its own set of hyperparameters. Nyan mentions the learning rate, which is usually associated with like neural networks, and as you go, other models will have different hyperparameters. So again, that's why my eye is drawn to that, because I want to know what hyperparameters are available, right? And so as N-Sweep mentions, you can think of it as different dials that you can adjust, that you can do experiments on, right? What I tell my staff, the people that work for me, I tell them, let's make sure we always have a lever to pull on, right? I think of it as pulling levers in a big machine or in a factory, right? You're always alive. You're always being able to try things as long as you have a lever to pull on, right? You're only dead. Your model is only dead or useless when there's no more models. There's nothing else to adjust, right? So that's how you should be thinking about it. So yeah, thinking about it as a dial, great way to think about it. Like I said, I call it levers. It gives you something to be able to experiment with. And that's another synonym you should be thinking about for hyperparameters. There are ways for you to experiment. So you can see that here, right? In lines 7 and 8 of the code, they are picking 2 hyperparameters, and then this list is the different values they want to attempt for those hyperparameters. Said another way, these are the experiments that they want to try, right? This is how you actually set up your data experiments. So I really hope you guys are seeing the parallels to the scientific method, right? These are the experiments. This is your experimentation phase. And as you can probably guess, we're doing 4 hyperparameters here, 4 hyperparameters here. So that means it's a permutation, right? So we're going to be trying 16 different experiments in this particular example, right? This is forming what's often referred to as a grid. And the grid contains all those different permutations. And now you can see here there's a loop. At line 16, there's a Python loop that goes through and tests each one of those permutations, right? You can see in the very first one, you're using all the parameters here, right? And you're going to go through and say, okay, here, this is what I'm fitting. These are the different things I want you to try. All right. So here again, we're verifying that we have everything that we need to be able to run our experiments. Here, it's telling you how to pull out the best parameters, because one of these permutations will, emerge as the champion model, right? So these are the combination of uses, combination of hyperparameters that you want to use, and then it goes on to tell you the different hyperparameters that can be tuned. It's known as a tuning process, right? Hyperparameter tuning. So these are the 4 that it recommends, and there's a couple more. Well, there's one more that's telling you that it's possible, and the others that really don't make sense to tune. And only they would know that because they know how it's how it's created, below the hood, right? I think there's one part. Yeah, I'm sorry. There's one part I did miss. And the last thing you should note here in this code where they're doing that tuning, they're also designating that RMSE is what they want to measure against. That's the metric that they're choosing to measure against. There's a lot of ways to arrive at that, but if you just wanted to say, well, I just want to use MSE instead of RMSE, you could. This is where you would change that. But the point is that you always want to make sure that you have that metric to measure against. Otherwise, you can't say one model is better than the other, right? All right, good. So we're going to leave the documentation here, and I'm going to go back to the deck because we're basically nearing a conclusion here, right? Because now we have all the components, right? We have all the components that we need. So I want to go back to the deck. Are there any more questions before I leave, the documentation? Last call for questions, and then we're going to go back to the deck. Actually, let me go back to. Anybody? Nobody? Okay. All right. So let's go back to our deck, and let's put a cherry on top here, right? Let's tie this all together. So now that we understand what we can do with this, now we can start thinking about projects. And here's 3 different ideas that you can consider. There is a lot of securities and commodities data that is great time series data, right? And think about the data structure that they gave you. The data is required is to give them the date and the Y value. So the Y value can easily be like a price of a security or a price of a commodity, right? Makes total sense to do that. What about sports? Sports usually fits a time series, especially for something like baseball, right? I mean, baseball, they play 162 games? That's a game every other day, right? That's like half the year. So you can use data like that too. There's a lot of time series data where I see opportunities for you to be able to use a tool like Prophet. You can use things like Yahoo Finance, right? Yahoo Finance makes CSV files of securities data available. So you can do that. Sports data has multiple resources out there that you can pull from, most of them free. And then on top of that, I mentioned that Meta also supports parallelizing. It supports that because when you're talking about hyperparameter tuning and you're talking about trying different models, there's, it can be intensive on the CPU. Some of these models, when I've run them in my own experiments, I've had to run for multiple days. Like not just multiple hours or multiple days. So some of these efforts can benefit from the parallelizing that that the Prophet can do. On top of that, these large-scale efforts, and I mention this because some of you asked me about becoming a quant. So in the quant world and in other worlds, there is a something known as alpha farming. Alpha farming is like the practice of trying to find a model or an approach that isn't popular yet or people just haven't found yet, like a brand new approach, right? A novel way to create returns, right? So you could take Prophet. If you really wanted to pursue this, you could create a large-scale alpha farming Prophet. Because think about that. You're going to take Prophet and you're going to pick something like the price of gold, and that's going to be your time series. So now with the time series, you can choose how many periods to use from that time series data, right? There was at least what, like, let me go back to that real quick. What do I want to do here? Yeah, there was at least what, oh, where were the hyperparameters? There's at least 1, 2, 3, there's 5 hyperparameters that you can use, right? And then each one of those has its own values. So now you're talking about multiple values for multiple permutations of those hyperparameters. And then you could also be talking about different commodities. Maybe you don't want to just do gold, you want to do silver, and then you want to do wheat, and then you want to do the price of IBM stock and the price of Disney stock or whatever, right? And then maybe you don't want to use the closing price, you want to use the opening price, or you want to use the midday price, or you want to use volume instead of price. And so you realize how quickly you can expand into this massive, massive effort. I'm talking about an effort that would take like an entire data center to do. But you know what, Mike, knowing the business and knowing what I know, there's probably companies out there doing that, right? I mean, I'm nearly positive there's probably, hedge funds out there that are doing something similar. Maybe with profit, maybe with their own tools, right? But like, this is what you do, right? You can go out there and say, okay, I have a pretty good time series tool. Let me go apply it to everything I can find. I'm going to apply it to every stock. I'm going to run 700 permutations of my hyperparameters, right? That's easy to do. And I'm going to run it against opening price, closing price, midday price, weekly average, whatever, in the hopes of finding that model that approaches zero with our metric, right? In this case, we chose MSE. Because, can we find a model that approaches zero with MSE to be able to create predictions? Because MSE is ultimately a measure of our predictive cycles, right? Sorry, let me go back to the deck. So these are the 3 projects that you could pick up today and start looking at. You're going to have to completely write, custom code. You're going to have to use some creativity on how you actually create the cross-validation, how you actually create the hyperparameter tuning, all of that stuff, right? You're going to need some processing power. You probably don't want to do this on CPU, although Meta does support CPU. I forgot to mention that. It supports both CPU and GPU. But these are the things that you can do and you can take on as projects. Okay? All right, guys. So that covers everything that I wanted to cover in terms of this project. So I hope that was helpful. I hope, maybe it inspires some of you to do more work with time series, or maybe you just want to, take your own framework. Maybe there's another library you want to study in the same way, right? You're certainly welcome to do that. All right. Any other questions on this? I'm going to look to wrap up the stream here soon. We've already been going for an hour 15. I can't believe that. But I will post a link to MetaProfit in the Discord. This video will be available on YouTube. But yeah, so last call for questions, guys. Any other questions on what we've covered here? Uh-oh, we might have lost everybody during the hyperparameter discussion. But it's been really great to share this with you guys. I'm usually not inspired to share project ideas, but I see a lot of potential in this particular library. You could come up with a ton of different interesting projects to add to your portfolio. And some of these would make great articles for when you're done, right? When you're done, these could be some wonderful articles. All right, last call before we wrap up, guys. Patrick says, this was awesome, extremely helpful, especially hearing about the methodology. Good. I'm glad, Patrick, because yeah, methodology is super important. Super important. I stress that with my younger analysts all the time. Okay, good. So Joseph, I'm glad you found it helpful. Nyan, great, thank you. Rex says, thank you for the inspiration. Great. Okay, so Hamad is asking an important question. What do you think about synthetic data? Chat, let's answer that. What do we think about synthetic data, right? The danger here, Hamad, is that synthetic data isn't always going to fit your real world applications, right? So do you want to use synthetic data 100%? No. Can you use it to supplement? Yes, you can. I'd like to keep that to a minimum, right? Like, just off the top of my head, maybe no more than 10%, right? If you come to me, right, and I'm your chief data scientist, and you tell me you want to use that, you're gonna have to give me some pretty good rationale for why. Like, why would you? And really, the only way I would accept that is if there was some like hard stop on why you couldn't get real world data. Like, I'd rather have you pursue the real world data, even though it's going to be hard, than to supplement with synthetic data. I like, you'd have to come to me with a pretty strong rationale for me to sign off on synthetic data. And even then, I'm still going to tell you like 10% max, right? Nyan says synthetic data is not really ever likely to solve real world business problems. Yeah, that's the danger, right? That's a danger, that you'd be simulating data and training on data that doesn't always happen, right? So yeah, so I'd be careful with that, Hamad. That's the danger zone, as they say, right? Rohan says, thank you for the insights. Yeah. Okay, real quick, I am going to answer just one more question, because Amina is reminding me, can we get back to why we should use a virtual environment, or did I miss it? So Amina, great question. Virtual environments are key because they help you segregate the different projects that you're working on. Why would you want to do that? Because you're going to have different versions of the same libraries that are applicable to multiple projects. So remember earlier we talked about how Prophet requires Python 3.7, right? Or maybe you need a specific version of Pandas. Pandas has been changing very, very quickly in the last like 2-3 years, right? Maybe one project requires this version of Pandas and another version of Pandas. I point out 3.7 because Python 3.6 was extremely popular. Python 3.6 was around for a long time, multiple years, right? So maybe you might still have things that run in 3.6 and can only run in 3.6, right? So that's what you should be thinking about virtual environments. They're like individual silos where you can maintain different versions of libraries and they never cross over. So you're never going to, have dependency issues, or, you work on one project, but you broke 3 others because you installed a bad version, right? That's what would be happening otherwise. But in a nutshell, that's why you would want to go ahead and use virtual environments, okay? So I hope that helped you. Hamad says, if data is not available, then I can't answer that. There's a lot of questions that pop up when that's available, right? Why is it not available? And if it's not available, then is this a model that you should be creating to begin with, right? Because if you're telling me that it's not available, then I'm thinking, well, then how often is this process used, right? If it's a process that's only used like twice a year for a business, then there may not be the ROI on the model to even have one, right? So I can't answer your question, Hamad. It just depends on the just the use case, right? Like, you'd have to tell me a lot more about that, right? All right, guys. So thank you so much. I'm gonna stop here. Join us on the Discord if you have other questions, but I hope this was helpful. Again, I just wanted to do something spontaneous and fun, so I hope you enjoyed it. Take care of yourselves, take care of your families, and I'll see you next time.